Hello students and welcome to my channel Maths Hub. So today in this video, I'll tell you about the particular integral case 7. So in the previous videos, we are dealing with how to calculate the particular integral of a second order differential equation. So let us see what is the seventh case. So before we jump into the seventh case, let us quickly revise all the previous rules that we have done for particular integral. So the inverse operator is 1 by d times q, which is integration q dx. Then rule number 1 was when we have e raised to power ax in the right hand side, we replace d by a. Then if on the second case we have sine or cos functions, then we replace d square with minus a square. If we have sine hyperbolic or cos hyperbolic functions, we replace d square with plus a square. Then if we have powers of x, then we take the help of binomial and we try to expand fd raised to power minus 1 in ascending powers of d till the terms of d raised to power m, so that we can calculate the derivatives term by term, and the rest of the derivatives, the higher derivatives than power m, will all become 0. Then was case 5, in which we have a product function e raised to power ax into v, and v can be any one of the functions that we have discussed before. So in this case, exponential comes out and d gets replaced by d plus a. And in case 6, we have done that if we have a linear factor 1 by d minus a, then it is converted into integration as e raised to power ax, integration q, e raised to power minus ax dx. And if there are no linear factors, we have a product of linear factors, and we can take the help of partial fractions. We can split all the terms in the denominator into linear factors, and then we can apply this rule separately, right? So now let's come to case 7. So in case 7, this is also a rule for product function, but now the product is x multiplied by v. That means one of the functions have to be x and v can be any of the other functions. It can be exponential, it can be sine, cos, sine hyperbolic, cos hyperbolic, anyone, right? So what does the rule say? X comes out, we operate 1 by fd on the function v. Then we write a minus sign, then we take the derivative of this function. Denominator, we take the square of this function operated on the function v, right? So let us try to understand this with the help of this exercise. So find the general solution of the differential equation d square plus 4 into y is equal to x into sine 2x. So general solution means we have to calculate the complementary solution and the particular integral. So for the complementary solution, I'm not writing much steps. So when we convert this auxiliary equation into an algebraic equation, we get m square plus 4 is equal to 0. So m square is minus 4. So what is your m? M is plus minus 2 iota. So our complementary solution will be e raised to power 0x, that is 1. So we have c1 cos 2x plus c2 sine 2x. So this comes out to be our complementary function. Now what is the particular integral? By p is 1 by d square plus 1, d square plus 4 into x sine 2x. So what did the rule say? When we have 1 by fd of the function v, it is x into v, sorry. So it is x into 1 by fd times v minus f dash d by fd square into v. So now let us apply this over here. So this is x into 1 by d square plus 4 operated on sine 2x minus derivative. So it is 2 times d divided by d square plus 4 whole square operated on again sine 2x. So now when we have to apply this rule, we have to apply the rule for sine now. So according to the rule of sine, d square gets replaced with minus 2 square, that is minus 4. Same thing here, d square gets replaced with minus 4. Now whenever you get d in the numerator and in the denominator, it's better that you remove the d from the denominator, because the numerator d we can take the derivative. So it's first that you should always eliminate d from the denominator. Now here you can see that the moment we replace d square with minus 4 in both the cases, what is happening? The case is failing, it's becoming 0. So it's a case of failure. Case fails, right? So if the case fails, what is to be done? What we are supposed to do? We will multiply with an x and we will take the derivative here, that is 2 times d sine 2x, right? Similarly here, what we are supposed to do, we will be multiplying with x and we will take the derivative of this. So this is 2 into d square plus 4 multiplied by 2d operated on sine 2x, right? So now this is x square by 2. What is integration of sine 2x? Integration of sine 2x is cos 2x by 2, right? So with a negative sign. Now from here, so you can see 2d gets cancelled and we have minus 1 by 2 x upon d square plus 4 operated on sine 2x, right? So again here we have to apply the rule for sine 2x. So that is replace d square with minus 4. So again this will fail. So we will get from here minus x square cos 2x divided by 4 minus half x. When the case fails, we multiply with another x and we divide by its derivative. So it is sine 2x, right? So now when we now apply the rule, so this is x square cos 2x divided by 4 minus x square by 4. Now 1 by d of sine 2x means integration. So we get cos 2x by 2. And this finally becomes minus x square cos 2x by 4. And then we get a plus sign x square cos 2x by 8. And then we have minus 1 by 4 plus 1 by 8. So that becomes minus x square, sorry, minus x square cos 2x divided by 8, right? And then what is my general solution? So the general solution y comes out to be c1 cos 2x plus c2 sin 2x minus x square by 8 into cos. So this comes out to be the right. So I hope this method is clear, right? So that's all. Thank you so much for listening. So if you like the video, do hit the like button. And those of you who have not subscribed to my channel, do subscribe my channel and share the videos with your knowns who need these videos to understand the topics, and believe in yourself and you will be able to succeed. Thank you.